Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. And in this video lecture we will study interpolation with unequal intervals. So firstly we shall understand what is the meaning of unequal interval. So far we have studied two important formulae. One was the Newton forward interpolation and another was Newton backward interpolation formula. In both these formulae, we were having equal intervals. What does that mean? Like we were given intervals, values of x. Like we were given 1, another one was say 6, another one was 11, 16. So here the spacing between them is 5. Spacing between this and this is also 5. Spacing between this and this is also 5, and the values of fx were given at these points. Say it is f1, at 6 it is f6, f11, f16. So values of the function was given at these points, which were equally spaced, So for that we were having Newton forward interpolation and Newton backward interpolation formula. Now what happens when the interval are not equal? Like here difference is 5, interval of differencing are not equal. Like we are given the values of x as 1, next one is 5, another one is 11, another one is 19, another one is 22. So here difference is 4, here difference is 6, here difference is 8, and here difference is 3. So the interval of differencing are not equal. So that means we are given unequal intervals. So in case of unequal intervals, we cannot use the Newton forward and Newton backward interpolation formula. Like we are given, these are the values of x, and say at point 1, 5, 11, 19 and 22. We are given value, say at 1 we are given value of function as say 5, it is given 15, it is given 20, it is given 30, it is given 40. So these are the values of function y is equal to fx. So firstly in the examination we will check the interval of differencing. Here difference is 4, here difference is 6. So immediately we will identify that question does not belong to the Newton forward and Newton backward interpolation formulae. It belongs to the unequal intervals, and for unequal intervals we use two formulae. Number one, two important formulae. Number one is Newton's divided difference formula, and for the second is Lagrange interpolation formula. And for the same, for both of these formulae we need to define divided difference. What is divided difference? Like we are given the values of x as x0, x1, x2, xn, and these values are not equally spaced. The difference between this one and this one is not equal to difference between x2 and x1. So these values are not equally spaced, and value of fx is f of x not at x naught, at x1 it is f of x1, at x2 f of x2, and f of x1. These are the values of function fx at the point x0, x1, x2, xn. Now we will divide the divided difference we divided the first order divided difference with respect to arguments x0 and x1. It is defined as f of x1 minus f of x0 divided by x1 minus x0. This is known as divided difference. Why divided difference? Because division is taking place. Division is taking place but between the difference of values of function and values of argument. These are the values of functions, and these are values of arguments. Since there is difference and this is the ratio, so this is known as divided difference. I think I am clear in explaining you what do you mean by divided difference. Divided means things are being divided, and difference means difference of value of the function and difference of the value of the arguments. These x0, x1, x2, xn are called arguments. These are called arguments. Once again I am writing, these are called arguments. Fine. So this is the divided difference, and this is known as first order divided difference. And symbolically it is written as f of x0 comma x1 is equal to f of x1 minus f of x0 divided by x1 minus x0. Fine. Okay. Now next we can also denote this thing as, see, this is delta, and divided means we will draw a perpendicular from here, this of f of x0 and the second argument here. This is read it as divided difference of f of x with respect to x0 and x1. So you will read it as divided difference of f of x with respect to arguments x0 and x1. Fine. So you will read it as something like this. Is also denoted as, within the square braces you will write the arguments x0, x1 with respect to which the divided difference is being taken. So it can be denoted by, this thing can be denoted by three notations. First is this one, second is this one, and third is this one. And in every case you will read it as a divided difference of f of x of the function with respect to the arguments x0, x1. Here also divided difference of f of x with respect to x0 and x1. Divided difference of f of x with respect to x0 and x1. In every case you will read it same, but it has three notations, and in your proof or anywhere you could use any of these notations. So I have put before you all the three notations. So it is up to you that which notation you want to use. So this is the forward difference divided difference operator of first order. Similarly we can define the second order. So now I will be defining the second order forward divided difference operator. Here let us take the second order. It will be denoted by f of x0, x1, x2, and read it as divided difference of f of x with respect to x0, x1 and x2. So how will do it? You will take last two and write it as f of x1 comma x2 minus, then you will take the first two and write it as f of x naught f of x naught x1, fine, divided by differences between the extreme arguments. What are the extreme arguments? It is very clear from here, these and these are the extreme argument, and you have to take the difference between them. So I'm going to take the difference x2 minus x0. So this is the second order divided difference, fine, and symbolically it is written as, this is delta, you know, draw a perpendicular from here, this is divided difference operator, f of x naught, one argument is here, two arguments at the below this divided difference operator, x1 comma x2, and since it is second order divided difference, so here will be 2, fine. Or it can also be written as symbolically within square braces write the arguments x0 x1 x2. By taking minus common, it could also be written as, if you take the minus common here, it will be x0 minus x2, and here also it will take x0 x1. So you can also write it first, then it second. So it will become x0 x1 minus f of x1 x2 divided by, here minus also, x0 minus x2, fine. So this is also the same thing, because we have cancelled the minus from the numerator and denominator. So this is the second order divided difference. Now we'll see how we'll write on the same lines nth order divided difference. So nth order divided difference will be, it will be f of x0 x1 up to xn. It has a n plus 1 argument, but it is of nth order divided difference. This will be, once again, take the last 10 leaving first, and then take the first n. Here will be a term which will be preceding to this xn, there will be term which will be x n minus 1, fine. So taking the first n and the last n terms, okay. So what it will be? It will be f of x1, this one I am writing x1, after x1 it will be x2, obviously, though it is not written over here, but it will be obvious, and it will be xn minus f of x0 x1 up to x n minus 1 divided by the difference between the extreme arguments. Extreme arguments are the xn and x0, so it will be xn minus x0, and this is also written as, this is delta divided nth order f of x0, and it will be x1 x2 up to xn, fine. So this is nth order divided difference. This can also be written as x0, x1, x2 up to xn. Fine. So this is nth order divided difference. So we have defined the first order, second order and up to nth order divided difference. Now we will see if two arguments are equal, then what will be its effect upon the first order divided difference. So we will see here. So if two arguments are equal, first two arguments x0 and x1 is also equal to x0, others are same, then what will happen to the first order divided difference? We have defined the first order divided difference as this one, so it will be, and this is the spacing. Let us say this is the line, you will try to understand, and this was the point x0, this was the point x1, x2, and these are not equally spaced, so I should be taking them unequally. This is x0, this is x1, another one is x2, another one is x3 and up to xn. Fine. So now x1 is very much close to this point x0. X1 is close to x0. So we can see x1 as x0 plus epsilon, where epsilon is very small, so small that it is approaching to 0. So in this I can replace, instead of putting x1 equal to x0, I could take x1 in the infinitesimal neighborhood of x0 by this thing, by writing x1 as x0 plus epsilon. This is also same thing of saying the x1 and x0 are coinciding, or they are infinitesimally close to each other. So in that case I will be writing the first order divided difference, that will be delta f of x0. It will be f of, instead of x1 I am going to write x0 plus epsilon minus f of x0 divided by, instead of it will be x0 plus epsilon, and here limit of epsilon is approaching to 0. This x0 to x0 will cancel, and by definition this is nothing but f dash x0. Similarly, if first three arguments are coinciding, in that case what we will get? We will be getting the second order divided difference, and how will you write it? I will show you. So here in this case, let us say this is the line, and in this case first three arguments x0, x1 and x2 are coinciding. So if we say this is x1 and it is very close to, this is infinitesimally close, is this is x0, this is x1, and close to it is also x2. These 3 points are infinitesimally close, so close that I could say that they are almost equal. Fine. So if I can say that x0 plus epsilon is equal to this one, x1, and similarly since x2 is at this place, so x1 plus epsilon is x2. So here if I put over here, it will become x0 plus epsilon plus epsilon. This will be x0 plus 2 epsilon. Okay, now we will define the second order divided difference. It will be f of x0, x0 and x0, because all have become equal. So this is also written as f of x naught. This is equal to, now let me write f of, if here would have been x naught, x1, x2, then this could be written as x1, x2, last two minus first two, x naught, x1 divided by the difference between the extremities x2 minus. Now they are coinciding. If this one and this one will coincide, so we will write the derivative with respect to the initial one like we derived over here. In this case, x naught and x1 were coinciding and initial point was x naught, so we have written f dash x naught. So here if they will coincide, so in that case I will write here, I will be writing f of x1 comma, it will x2 in place of x2 I will write x1 plus epsilon minus f of, it will be x naught and it will be x naught plus epsilon divided by, this will be x naught plus 2 epsilon minus x naught, and you can write as limit epsilon approaches to 0. When this will be applied, this thing is equal to, first argument is x1, so this will be equal to f dash x1 and this will be f dash first argument f dash x naught divided by 2 epsilon and limit epsilon is approaching to 0. Once again x1 can be written as limit epsilon approaches to 0, 1 by 2 is a constant quantity, so it will come out, this will be f dash x naught plus epsilon minus f dash x naught divided by epsilon. This is by definition of differentiation, this is nothing but f double dash x naught. So this implies that divided difference of second order when first three arguments are equal is equal to 1 by 2 factorial f double dash x naught. Similarly, we can define an nth order divided difference when all the first n plus 1 arguments are equal. What will be its value? Like here 2, here is 2 factorial, here is 2, here is 2 time differentiation. So in case of n, I'm going to write it as divided difference n f of x naught is equal to 1 by n factorial, this will be f of n and this will be x naught. So this is the divided difference when the first n plus 1 arguments, all the arguments are equal. So that is how you will write. So that we have also expressed the formula for divided difference of all the orders when the arguments are equal, that we will be using while we will be doing the proofs. So in this lecture we have studied what is interpolation with unequal interval, that is to find any value in between them. Like we are given any value, we are required to find any value between x1 and x2 of the function and intervals are unequal, so this is known as interpolation with unequal intervals. In that we studied that what is divided difference and what are its various order and how to define the divided difference of various different orders. And then we studied that if the first two arguments are equal, then what will be the definition of the first order divided difference. If first three arguments are equal, then what will be the definition of second order divided difference. And if first n plus 1 arguments are equal, then what will be the definition of the nth order divided difference. So that we have studied and we have derived. So that's all I have from this lecture, and I hope that you will be able to understand the grasp the idea of divided difference. In the next lecture, we will be deriving the property related to divided difference. Okay, and so that's all I have from this lecture. And if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care and see you soon.